Hi there everyone, and welcome to the second episode of Ask a Physicist. Now, Dolaros GP asks, what are black holes, where do they come from, and what evidence do we have that they exist? Well, let me start by saying that black holes are still a bit of a mysterious topic at the moment. In fact, many world-renowned theoretical physicists, including Stephen Hawking himself, are still working on problems relating to black holes. However, there's a number of things about black holes which we know quite well, and which I'm able to explain, I hope. And if you look at it, they really aren't as scary as you might think. First of all, what are black holes? The two things you really need to understand to grasp the concept of black holes is A, gravitational force, and B, the concept of escape velocity. As you hopefully know, gravity is the force that pulls you towards the ground. More than that, gravity pulls all objects towards each other. For instance, the moon towards the Earth and the Earth towards the Sun. That's why they stay in orbit. Objects that have a greater mass, like planets or stars, exert a greater gravitational force than smaller objects, like people. Now, imagine you're standing on the surface of the Earth and you fire a cannon straight towards the sky. The projectile of the cannon will travel upwards at a great velocity, but due to gravity it will decelerate and eventually drop back to the ground. If you fire the projectile with a greater velocity, it will travel further before falling back down. Now, if you shoot the projectile fast enough, it will escape the Earth's gravitational pull and will essentially keep rising forever. The velocity at which this is possible is called the escape velocity of the object, and for the Earth it's about 11 kilometers per second. Now, if the Earth was made out of solid lead, in other words, if it was denser, it would have a much greater mass, and the gravitational force exerted by the Earth would be much greater as well. In turn, the escape velocity from the Earth would be higher. Okay, so how does this all relate to black holes? Well, by definition, a black hole is an object so dense that it produces a gravitational force so great that its escape velocity exceeds the speed of light. However, nothing in this universe can travel faster than the speed of light. So, essentially this means that anything that gets too close to a black hole, say a spaceship, or even light itself, will not be able to escape and will be pulled towards its center. The area which marks the distance from the center of the black hole from which light cannot escape is called event horizon. Today, two types of black holes have been discovered. First one being stellar black holes, which have about 10 times the mass of our Sun, and also supermassive black holes, which have more than 1 million times the mass of our Sun. Okay, now to our second point. Where do black holes come from? First of all, let's look at stellar black holes. Stellar black holes are made from dying stars. Not stars like our Sun, because it's too small and stable. However, stars which have about 30 times the mass of our Sun can burn out very quickly, and when they do, can turn into black holes. Now, how does this work? Well, as I said, gravity causes all objects to attract each other. So in actual fact, a star is nothing else but countless numbers of hydrogen gas particles all attracting each other to form a big gaseous sphere. You see that in this formation, every particle attracts particles from the other side of the sphere, which generates great pressure in the center. Enough pressure to initiate nuclear fusion, which releases lots of energy. This is why stars are bright. However, when they have no fuel left to initiate fusion any longer, there's nothing to push back against the pressure caused by gravity, and the star collapses. Small stars like our Sun collapse to a tiny fraction of their original size and remain as white dwarfs, supported by the degeneracy pressure of electrons. For big stars, on the other hand, the force that particles exert is so great that the structure of the star breaks down completely and collapses into a single point of zero volume and infinite density. The result is a stellar black hole, and they can be found throughout the universe wherever these massive stars have first formed. Supermassive black holes, on the other hand, are found at the centers of galaxies only. However, their origin is still a bit of a mystery. To our third point, how do we detect black holes? As I said, since black holes don't allow light to escape, there is no actual way of seeing them. However, there are a couple of ways in which you can detect them nonetheless. For instance, since black holes have an enormous gravitational pull, they can affect the paths of nearby stellar objects. For instance, a supermassive black hole at the center of a galaxy could affect the paths of nearby stars. If we can detect such a deviation, we can determine where there might be black holes. Also, when there is another object nearby the black hole, it is of course possible that the black hole attracts matter from that object and pulls it towards itself due to gravity. The stuff attracted by the black hole will start swirling around it, forming what is called an accretion disk, as shown in this picture. The matter in the accretion disk becomes very hot when swirling closer to the black hole due to the increased traction. Now, this may not be obvious to you, but all hot objects release radiation. Hence, through the process of accretion, black holes can become quite bright objects, which you can detect using telescopes. Okay, Skippy, I hope that answered all of your questions for now, and I'd say, if you understand all what I've just shown, you should have a pretty good basic understanding of black holes. Well, there are of course a lot more things that could be said about black holes, such as about the singularity at their center or the Hawking radiation they emit, but to be honest, I would have to read up on those things myself, so let's leave that for another time. So, that's all for this episode of Ask a Physicist. I hope you enjoyed it, and please do feel free to comment or to ask a question yourself. Thanks for watching.